finishes. So let's say if I run with a blank, if I have just the setup and the loop, we notice it actually works for us. So just the setup and loop function alone to get it running, it makes use of 444 bytes of memory. That's one. So at the moment, we know that the code that we have so far makes use of 892 bytes of memory. And we want to find a way to use that memory space. Okay. So we press the push button, then it comes on. We let go, it goes up. Quick summary of the project. Basically, we've got push button going to pin 2, LED pin going to pin 5, and then we've got input pull up to connect it to 5 volts. And because by default it's connected to 5 volts, if we basically press it's going to get connected from pin 2, it's going to get connected from the between the switch and back to the ground, and hence it will be 0, and hence if we press it will be 0, and then we say okay, set the LED pin on, otherwise set the LED pin. Let's try to see what we can change or what we can manipulate using direct register manipulation to improve the memory usage of the code that we have. Our switch is connected to pin 2 and our LED is connected to pin 5. So if we go back, the switch is connected to port D2 and the LED is connected to port D5. First thing we want to do is to set the direction. So basically we comment this out and then we say data direction register D. What do we want to set D2 to a binary value? If we jump all the way to input and output port, you notice that for each pin, there's the pin that we have. For each pin, we can actually connect to an internal put to a 5-volt source. If we go a bit down to the register description, you've got an overview, you've got general I/O, and you've got stuff that you can use. If you go to the register description, you've got for each one, we've got the port, we've got the data direction register, and then you've got the pin. So each port is 8-bit wide, so 0 to 7, and then you've got the corresponding pin that you want to use. But we are interested in port D because we are making use of pins 2 and then pin 5. Right. Arrow in the data direction register makes it an input. So by default, these are the initial values. So by default, all the pins are set as an input. So DDR5, we want it to be an output because it's connected to an LED. We need to put a 1 here. Because this is an input, if we want to set it to the pull-up resistor, we need to put the corresponding pin 1. So an input, if you send a 1 to the port, then it just becomes input pull up. But we can also switch off the LED because it's an output by sending a 0 signal to it as well. Then we can read the status using the pin as well. So with each of them 8-bit wide, that's what we make use of. Okay, so let's put 8-bit binary. So that is B for binary. We say 1, 2, 3, 4, 5, 6, 7, 8. Make sure bit 2, which is the one highlighted now, is set as an output, right? Bit 5 should be an output because it's going to the LED. LED goes to bit 5, so that becomes a 1. And then we put semicolon to end it. What we've done so far is to set bit 5 as an output and then bit 2 as an input. Those are the only ones we are interested in. But remember so we want the input to be input pull up. So I will just comment these two out to the bottom. Which port are we interested in? Port D, and D we want to basically the same 8-bit. What we are interested in is the input pull up. So input pull up, we want to set bit 2, which is now an input. We want to set a 1 to it. And then we start the simulation again. So far we we put the switch off, we put the LED off. We had it being put back on at this point and nothing else happening. And then we've set the switch to input pull up, because when we run it, at the moment, the LED is off. And if I press, the LED comes on, which is the code that we expected to happen before.